Hey everybody, this is Larry. This is the last, wait, no, it's not. I lied. It's the first day of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And I'll be doing the premium problem as well. So stay tuned for that video. I have my current streak is 1248. So we're going to, so we're going to be doing this all month is what I was trying to say. Man, I am a little groggy right now for whatever reason. But yeah, so join us, even though today's problem is easy. Or, it's marked easy. But, it may get tricky. So let's do it together. Let's all get the streak going and let's keep going. Alright, today's problem is 338, counting bits. Given an integer n, we turn an array answer of length n plus 1 such that each I is the number of i's or number of ones in a binary representation of I. Okay. I think the obvious thing is just loop and whatever. I would also say that just for y'all at home, Leetcode is actually very wrong here. This is not linear time. It is O of n time, but O of n time isn't linear time. In this case, it is O of small n, or at least O of n as in the input, because this is not linear time, because when people say linear time, it is meant to be linear in the size of the input. And maybe this is pedantic, but listen, pedantic is annoying until you get robbed on an interview, right? So you want to make the mistake. You want to listen to some annoying guy from the internet, before you listen to some very sad recruiter or interviewer telling you that you're wrong or whatever, right? But in any case, it is the size of the input, and the size of this input is the number of bits representing the number n, and of course it takes log n. It's confusing because the input is n, but it takes log n bits to represent a number n. So technically, this is always going to be exponential. This is because even if you do it over small n, as we said, that means that there's you could do some substitution, but at the end of the day, it's just going to be like 2 to the n. It's exponential because let's say n is equal to, I don't know, 128, right? 128 or 1024, say. 1024, that's 10 bit to represent it. You're doing a loop for at least 1,000 times. That's exponential. In any case, I know that I'm spending a little bit of time here, but I want to kind of get this focus on this linear time. And of course, and even this notation is a little bit sketch in that sense. I'm not gonna lie, even I use it sometimes, but using this notation isn't the same as linear time, saying linear time per se. But definitely make that, make sure you don't make that mistake, I guess, like they do in Leetcode. And it's something that I talk about actually a lot, but it's just at this time today, they happen to have it on the problem itself. And this is also why, this comes into play a little bit more when it comes to actually, I guess this kind of problem where you have an input that is a number and then it comes into play, right? Because I think the biggest one is prime factorization, for example. Why is prime factorization not quote unquote linear? And people call all this other stuff and NP and all these possibly and all this stuff, right? Well, it's because it's the number of bits, not the number. That's the TLDR. Anyway, you could do more research on it if you like, but didn't want to dwell on this, but maybe dwelling is okay. It's easy, so it's not that bad per se, right? And then n log n would be in this particular case, I guess n times 2 to the n if you want to convert it to the size of the input n. But that's just looping every number, counting the number of bits and so forth. That should be simple. I think the other way to do it, and of course you can do it with built-in functions like build popcount or built-in popcount. In Python, it is just you could do you could do this. maybe technically, I mean, to be more precise, you can do something like this. But of course, I think actually there is a, depending on the version. I think some of the new Python, the new Python version has something like this. Is what I meant to say. I just want to check it real quick. I forget if this is the syntax, to be honest. I mean, we'll actually work on something a little bit better, because this is just a silly, okay, so what are we supposed to return? Oh, I misunderstood this problem, but yeah, you get the idea. I for some reason oh, yikes, but yeah. Times. Maybe this is fine. Yeah, okay. Maybe I'm lazy to do the math on the log. Something like that, right? And of course, this is fine. I mean, I didn't kind of wrote this actually in a little bit of a silly way. And also, I did it the other way. Whoops. Now it's going to take 10 seconds to run infinity. I don't know. My implementation has been very sloppy lately. Okay. Did I misunderstood this form? Zero. It goes from. Maybe am I thinking of something else? 1 and 2. Oh, I actually misread this, but okay, I see what's the situation. It's the number of ones in the, wait, no, wait, why is this in the binary representation? Oh, I see. I actually misread this. Okay, again. I mean, it's still the same core idea, but yeah, okay, fine. Man, I am really silly today. Right. So okay. Anyway, that wasn't my point. Anyway, apparently my point is that I cannot read, and I have tens of people or hundreds or whatever. How many people is watching this? Know that Larry is apparently illiterate, but that's I mean, and this is fine, and you can submit it, and it'll be fine. Assuming you read the prompt ultimately correctly, but whoops. But yeah, but let's actually solve the problem in a better way, in what they call O of n times. I mean, this is so. The first thing I would say is that. The first thing I would say is that this is going to be O of n space. Why? Because, well, that's the size of the output, right? So you can't really do better than O of n space, at least not, not, or like you can maybe redefine extra variables with respect to like extra space or whatever, but at its core, the lower bound is going to be O of n, right? So, okay, so let's take a look at that. And then, so this is basically an idea. Another idea is just dynamic programming, and maybe day 1 of September is dynamic programming is a little bit tricky thing, even though that's a follow-up and they don't really rank on the follow-up. But the idea here is that I was going to say you could take either the most significant bit or the least significant bit, but least significant bit is much easier because then now you can do something like so plus I mod 2 or something like this. I don't know if I'm off by 1 here, but it should be okay, right? And maybe this feels a little bit yucky for 0. I mean, technically it's correct just by luck, but I think, technically still not correct for 0. So I think this should be good. The idea here is, I'll just do a visualization, right? For example, let's say you want to do 5 and I'm 5, and I'm going to do this in binary because this is a binary problem. So here you just count. Okay, well, how many ones are there? The number of ones here is if we take off the last bit and then and then you could do a count here, which is what this mod thing does, and you can also do n1 or whatever, bitwise n1, but and then count the number of the rest of the bits, which is what this thing does. It's a little bit, it's a little bit, and I think that's one of the ideas. I think with respect to complexity, these things are always, did this change? It looks a little bit different, or maybe it always had been, I don't know. The idea about complexity is actually kind of tricky, to be honest, to kind of get this really precisely right, especially when we think about calling the size of the input bits as the thing that we're differentiating, right? Because, for example, let's just redo the vocabulary slightly, where we say n is equal to, so instead of n, we have m bits as input size, right? And then here, this is going to be 2 to the m times m, right? Something like this. Yeah, because this number will have m bits. Actually, technically, it doesn't have to be, but depends how you want to define the limit, because the number 2 to the m, that's actually tricky. The number 2 to the m will have at most m1s, and m1s can be represented as log m bits, right? So if you really want to be precise, and you don't have to be because whatever, but if you really want to be, technically, this number can be represented as log m bits, right? So which makes this for space, right? I don't actually know which way is cleaner. Is it 2 to the m log m? I don't know. So that's space, right? And then time. Well, we have a loop here that takes 2 to the O of 2 to the m iterations. And here, this is what my motivation is that, okay, so this takes, let's say generously O of 1. I don't know if you can say that, because technically you can't just like look at one bit of a number very easily, and because you can't just like look at it like an index to an array or something like this. So, but either way, this part divided by 2 is a right shift, and you can say maybe it's O of 1 in the sense that I think this is very often an operation on the bit set or on the chip set, meaning your processor will very likely have something like this for right shift, even though we didn't do a right shift, but the same idea as a right shift. And I think I don't think or know whether Python optimize this, especially since this is an integer division, but in a lot of languages, this will probably get optimized by the compiler into a right shift of 1 is hard-coded constant and stuff like this, so to make it even a little bit faster. But in that case, so you can think about it as either O of 1 or O of m. I don't know how you want to think about it, because there is some nuance in kind of tricky in how tricky it is. Yeah, so you could say this is either O of 2 to the m or m times 2 to the m. And I mean, maybe it's good to say this is O of 2. And technically you could maybe, yeah. Let's just say this is O of m, because I think that makes more sense. Wait. No, this is, this is the input size. Okay, so the m bits, fine. I was going to say something like this addition actually also take O of m, but technically that's not true. Technically, like we said, it takes log m space to represent this number. So technically, this addition would just be O of log m time, but then it gets dominated by this O of m thing of this right shift. Maybe we should look it up. So I don't know. Anyway, this is an unnecessarily in-depth analysis of this problem, or off my head and or live. So definitely let me know what you think. Let me know if this is too intense. We'll see what happens. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.